Hello world! Welcome back to another picoGym workout exercise video. In this video, we'll be walking through the binary exploitation challenge, heap 0. Let's get into it. Are overflows just a stat concern? Download the binary here, download the source here, connect with the challenge instance here. Alright, I already have the challenge files downloaded over here, but we're going to start off by connecting to the netcat portal first, just to see what it looks like. Welcome to heap 0. I put my data on the heap so it should be safe from any tampering. Since my data isn't on the stack, I'll even let you write whatever info you want to the heap. I already took care of using malloc for you. Then it shows us the heap state. One prints the heap out, so we'll do that. And we can see our heap state here is the same as what it printed out up here. We can see pico and bico. Then we have write to the buffer. So if we do that, we can put in some data. Now let's try printing the heap, and we can see our data right here, and bico didn't change, so bico must be something else. Let's try printing the safe var right here with 3, and we can see that bico is our safe var, and then we have print flag, which of course is not going to print the flag for us yet because we haven't exploited it, and then we have 5 for exit. All right, now let's take a look at the source code, which I already have open here, and I have it scrolled down to the main function. We have our init function right here, and if we scroll up to our init function, we can see that it prints our welcome message, and then it also sets up our input data with pico, so that's a default value that it's storing initially inside of the input data, and then our safe var, which is bico. Going back down to the main function, we see print heap is called next, and print heap is essentially just printing that heap table, so it does that initially from the get-go regardless. Then our name function has a loop set up, and then it starts off by printing the menu, and we know what the menu is. The menu is going to be those 5 options that we have to select from. And then upon our selection, we can see these cases here, and our case 1 prints the heap, which we know what that does already. Case 2 writes to the buffer. We'll go take a look at that write buffer function. Data for buffer, and it stores it in the input data variable. We saw the input data variable getting initialized to pico originally, so it essentially copies our input in place of pico. So pico gets replaced by our input. Then we have 3, which prints the safe var, which we know to be bico, based on this right here. And then case 4 checks when, and check when is comparing the safe var to bico, and if it's not equal to 0, then you win. This essentially means if we're able to override the bico variable with anything else, then we get the flag essentially. And that's because strcmp returns 0 if the values that are being compared match each other. If they don't match each other, then it won't be 0. So let's take a look back at our write buffer function, as that's where we'll be sending our exploit to. And we can see that from the scanf that there's no bounds checking, which means we can put as many characters in as we want. Not only that, if the address of where we're inputting our data occurs before the area that we're actually exploiting, then we should be good to go as far as exploiting this. And we can see based off of the heap state that our input data, or where our input data is located at on the heap when we enter it, is stored at an address before the address of the safe var, which is the variable that we want to exploit. So we have all the pieces we need in order to install this. All we need is the offset in order to reach the bico variable via whatever overflow we put in. And we can do that very easily by subtracting the address of our input data from the address of our safe variable. So let's go ahead and do that. We can do that in Python. And what we'll do is we'll copy bico, paste it here. We'll do minus our other hex value there. We can see that our offset is 32. All right, now we know how many characters we need to offset by in order to overflow the safe var. So let's go ahead and reconnect to our netcat portal. We're going to enter 2 in for our choice. We're going to submit a 32 character string. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, V, W, X, Y, Z, that's 26, 27, 28, 29, 30, 31, 32, like so. Now if we print the heap, we can see our input here, and we can see that bico no longer appears here. So that means we've successfully overridden bico, or our safe variable, and we can even print our safe variable, and we'll see that nothing's there. So now we should be able to just print the flag out, and there's our flag, my first heap overflow. So we'll copy that, paste it into our flag submission, and submit. All right, if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comment section down below. This is Alma Milk. Thanks for watching. Goodbye, world.